Hi, today we will work using Azure SQL DB in serverless mode. This is a practical use, so let's start. Um, my name is Carlos Lopez. I'm a Microsoft Data Platform MVP. I'm a blogger, speaker. I work in a community in Guatemala where I live. Here are my networks. If you want to contact or reach out, please, with, you can do it. Okay, let's start. The agenda for today will be covering three main aspects. It's real short, but it will be just a glance to each subject. That'll be the Microsoft Azure SQL overview, verifying the tools, and the architecture for it. We'll discuss about the Azure SQL provisioning modes, the compute models and features, and lastly the Azure SQL consideration, checking out some scenarios, just some thoughts that you might come in handy when considering using it, and the features that you might need. So let's start. The Microsoft Azure SQL overview is the first part. So this is an introduction, and here are the tools and requirements that you might need to connect. So basically, you need an active subscription on Azure with your Microsoft account. Uh, the Azure portal, of course, where you can administrate everything. The Azure CLI, which you can interface the commands as well as the portal. And so we'll discuss the same commands that we do on portal. Um, Also, we will use the Visual Studio Code with some features that might help us, including Azure CLI and others. The Visual Studio Code, Azure Resources, resource groups, and the DB, and the SQL Server extension to connect to the databases, and finally and lastly the Azure Data Studio to connect to the SQL databases. So this is the small glance of features that we will be discussing here. So let's talk about a little bit about the architecture model and the compute models for it. So here are the two different ways that Azure managed their resources for CPU. Here in comparison, you can see from the left side, you can see the DTU model and the vCore, which is the independent and scalable, which is the basic solution that we are seeing here, which is independent for scalability, IO resources, and best for customers to gain value. So this is what is used. This model is what is used for Azure Hybrid, and in the way that we're seeing the cost saving for the Azure SQL. So we always ask ourselves how this provisioning model works, how it works in the background, what it makes it possible to work, how all that works together to allow us to work with the almost instant declarative service model that we see. So here is the Azure Fabric Mesh that allow us to manage the microservice platform, where we see all the services together, working together. We see all this provisioning model where all this work together in the backend. This is the actual service mesh that allows us to see all the features that work there. So basically, we're seeing that it's no secret that it works over containers and a serverless infrastructure model. So this is what allows us to to use the resources when we want and how we want, and to destroy it whenever we want, just as easily as we build on this Azure Service Fabric Mesh. This is what it makes it all possible. So I think this is important to see because it definitely makes operations and everything works together. When we see it as Azure DevOps pipelines and all working together, we understand the value of everything working as a CI/CD. It is the service fabric mesh that allows us to work it. So uh, these are the three models that these are the three languages, sorry, to that allows us to work to the as a declarative mode in a common way. So here is an example. We can see a YAML file where we can declare the operations that we want to construct. So we can see the DACPAC file where that allows us to create in a pipeline, an Azure pipeline to execute. So to create the same infrastructure, the same containers that we're seeing in the future. So this is a way to do it. The other, you can see the second one is that Azure CLI. You can throw commands there to connect through the console to create, to see the resources, to finally create your SQL server and to delete and list all the objects that you need. So it allows you to do the same things that you do at the portal. So we'll try to do that here in our example. So this is the example that we took from there, the snapshot from the example that we will execute in a couple of minutes. So this is the third way. When we see creation of an object or a container, we see a JSON file. Here is the result. Here's an example of the parameters and all the configuration for it. You can see all the infrastructure, how it is created. And this response is through the service mesh that we have discussed. So this is the beauty of it is that allows us to view, to record, and to handle in a different ways that we want to manage. So this is a graphic way to see the JSON that of a database that we have created. Okay, now let's talk about a little bit of how to provision a SQL server, Azure SQL in serverless mode. So here are we have 4 service model, scalable, intelligent, and with almost all compatibility with the latest SQL Enterprise Edition. So the first one is the managed instance that allows us to preserve all the platform as a service capabilities with automatic patching version updates and reducing overhead. So what it is here is that managed instance is designed to allow us to migrate from on-prem to infrastructure as a service, right? So, but it is not quite a container. It is a machine with a SQL server inside it, infrastructure way to see it. But these 3 models are containers in for a SQL Server, where we have the SQL Server as a Linux inside. We can see we don't need that OS, Windows OS that traditionally we know. So we will discuss serverless for today, and the provisioned and hyperscale are like the more powerful ways to manage the same containers with more resources. However, it is the same concept. Here it is a graphic to let us see what we can manage when we are on-prem. It's a distinctive way to know that here on-prem we own all the infrastructure and we have the SQL Server and all the layers here. But here are how it is for a managed instance and how it is for a serverless and provision and hyperscale, where it is practically a software as a service with all the layers are taken care of for us. So we only use what we need, the SQL Server, whenever we need and however we need it. So this is a good use for it. So a difference that managed instance, you can see that you have to manage your own data layer and your SQL Server that will be here. Next up, we'll see the deploy and server and database. What we need is to define the resource in this order is to define a resource group. We have to create a resource group where we will create the network configuration and firewalls for the resource group and define a compute tier, which is provision or serverless. Here we will use serverless. Next up, we'll define a SQL elastic pool if we have one or if we don't need that. This is basically depending on your performance on the database that you're using and if you need it or not. In this case, we will just use for example purpose, so we won't use an elastic pool. Then we'll define a storage associated with it or created one. And then define a compute family, which allows us to segment in between generation 4 and generation 5, depending on the performance or the disks that you want to read on here. This is the looks like when you choose all these options in the Azure portal. You have to select the general purpose. You have to select serverless because for default is as provisioned, so you have to change it to serverless. The difference between serverless and provision is that provision will, as it in this concept say, it will provision your resources there as a default. So here are the characteristics that you need. A generation 4 compute model that will create, a service model, a service objective, an auto pause, an auto scale, and a service pool. This is what you have to identify as characteristics when you are creating a serverless SQL Server. So real fast scenarios, when you think when can we identify when we need a serverless and a provision model. When we need a serverless, we can identify that we need and terminate use of the inactivity use periods to save costs. A database designed to scale up and down during a time. A new application maybe, and data whose resources are not predictable or easy to estimate. Then we can assume that we can create a serverless or it can be used for us. Then in a provisional model, we can identify a database with predictable use in a long term. To identify pre-allocated resources, we can use for business important. For then we need provisioned model. Also, we can select using hyperscale or business critical in your service tier, depending on what you need, the performance you need. Because another characteristic is you cannot tolerate delay, auto resume, auto pause. You cannot tolerate constant memory claim actions, which is part of the serverless, in a way to save costs. And you don't have elastic, you need an elastic pool maybe for these kind of databases. So then you need a provisioning model. So when you select this Azure SQL, you only pay for what resources you consume. And for serverless, you only support it in a general purpose license. You have max memory allocation for size 3 gigabytes per core, compared with 5 or 7 in provisioning mode, depending on the CPU. You have 40 vCores max for serverless, and you will experiment a 1 minute delay when it goes to auto pause and auto resume. So these considerations are important for you when you are trying to use your Azure SQL and to connect with the application that you select to test it. So here is Azure SQL Insights. This is a new feature for the Azure SQL databases that allows us to see the performance in a different way. It actually captures all these DMVs, or the dynamic management views, that Azure allows us to see in Azure SQL, and capture all these metadata and transport it into a SQL, another databases that where it records everything that is there, and you can report it. So this is a cool feature, and it's highly recommended to test it. So it is on preview. However, it is highly recommended. In terms of cost, it doesn't it doesn't have any cost to see the Azure and the record. The only thing that you need is a Linux VM, where the database will for performance will be storing. So that is your cost. The VM where this performance DMBs will be recording. So um, with this Azure SQL, we have a great power, and with great power, it comes a great responsibility. So we can see it as a different perspective, but it is important. So now let's go to a quick demo of how we check some features that we just discussed. First, we will check out some commands that we have discussed. This is testing the CLI to interface the Azure. So we can see. Let's start with checking out the group list. So here is the command. As you see, the result is a JSON where we can see all the resource group there. We can see all the configurations that I have on my account. So what happens if I want to check out specifically for a particular server? So we can do a query using these kinds of parameters. We'll use a query using the location. So we can query out as a East US. So everything is on East US, so it will list a lot. So if we want to be more specific, we can query out as a server, a specific server that we're looking for. So here it is. Here is the creation, and this is the provisioning model that we have, the location. So now we can create a resource group like this. In this case, it won't let me because it already exists. We can do as a number 2 to test it. So it'll create another resource group. So we only need the location and the name. And here is the status. So it let us know that it succeeded and have created. right? So now we will create a SQL server directly, specifying the location, the service, the group that we are creating. We have created for this one the servers 01, the name of the server that we are creating, and the user that will use the SQL server. In this case, we will create a number 2. We will, all right, and we'll execute. This will take some time. It is running, so as you can see. So while it does it, I'll just check show you that we can see that as the way that we listed the resource group, we can see the list of SQL servers that are in the resource group. In this case, the number 1. The problem is that I'm been using this bash, so since it is running, I'll create another one and execute the list to see the SQL server. And the response is a JSON, as you can see, and it can shows you the name of the server, and it can identify the names of the databases there and all the results that you need for it. Okay, so right now we will create a SQL database now that we have a server. How we do that is we simply specify the SQL DB create to the same resource group that we have created up, above in the server that we have created, and here we create the new name that we have discussed, that we are setting up for this database. In this case, I will change the number. I'm using the GX45 in a general purpose license, in a family generation 5 with the minimum capacity of 0.5, and a serverless model. In a difference, you can see it in your GUI, and you have to select. I'm doing the same, just but command, and I'm selecting the auto pause to 60 minutes. This is the default, but I'm just using as an example. Here you can select the service objective that you're looking for. So I'm putting an S0. You can change it. We will change it in another tool further in example. Sorry, and also you can select the backup storage redundancy. You can use it geographically or local. Also, the collation, you can set it up, and I use the default for SQL Latin, that SQL Server Manage. So I'll execute here, and I think that it will take a while to execute while it's running here. Let's see what happened on the other bash. You see the response, we have the response here on the creation on the SQL Server that we just named different here, the SOCMecha 2. So here we have another SQL Server here. We could just list it in our resource group. So what happens if we locate and list everything that comes in East US? It will appear there. You have it right here. So it lists the CR server 1 and the CR server 2. Just as easy. And in the second bash, it is still running the creation on the serverless. For the CR server number 1, we are creating the GX45. So while it is running here, we will go, oh, it just finished here. It didn't find the service objective. It failed because the service objective was not recognized. We have to change it. But let's try to see it in a graphical way. Maybe we can see it in an SSMS. Let's check it out. So here it is. We're not now connected to the SOCMecha server, where we have created the GX45 database, which was successful. And now we from here we can change the purpose of connecting through the SSMS is to show you that we can change in a GUI in a standard way. We can change the SLO in a graphical way. Sorry about that. I need to connect. Okay, so we can change the addition. We can change it through the service purpose that we need, which is hyperscale, business critical, and general purpose that we were discussing previously. So let's stick it with general purpose, and we can change the level, Serverless level objective, which is the general 5. Here are all the list of service objective that you can select. Remember that everything that you're seeing here has a cost, so it'll depend on what is the criticality of your database. So you have to be careful with that because it changes the cost. So here is the max size of the database. You can change it. For default is 32 gigs, but you can change it to a different size to 33 and 1 gigabyte at least. So that depends on the size of your database and the performance that you need. So you have to go and test. If you need more resources, you can change it from here. So that is what the purpose of this graphical way to show you. This is another way to create using the tsql command, as always, to create a database, a name, selecting the edition and the SLO, the same that we did in the declarative mode for Azure CLI. We can drop databases as always, and here we can see the SLO selected for this database, the edition, and the service objective. Here I have commented some of the SLOs that you can change in your edition, and some queries that you can use to modify. For example, if we can alter the same way that we did graphically. We changed the general purpose and the service objective to S0. Also, you can use it to change the elastic pool, but since we don't have any, so it won't do any alteration. So basically that's it for our testing, our quick test for using Azure SQL Serverless. Thank you. Here are my networks if you want to hang out and know more details about how to use Azure SQL Serverless. Thank you for being part of this event.